Hi everyone, this video is going to walk you through the implicit differentiation formative assessment that we gave in class the other day. I know a lot of students really struggled with it, so I wanted to make sure that I walk you through how to do these problems, and now you'll have a resource for the rest of the year because this is not going to go away. Implicit differentiation is something you are definitely going to need to know for the AP exam. So let's take a look at number 1. It says x squared minus 3xy equals 10. Use implicit differentiation to find dy dx. Well, first of all, we know we need to use implicit differentiation because the y is not solved for. So anytime y is not solved for in our equations, we need to apply implicit differentiation, which really just means remember to use the chain rule. Any place that you take the derivative of y, you have to remember to put a dy dx. So everything else though is just normal. Just take the derivative. So if I want to take the derivative of x squared, that's just 2x. And then I'm going to do minus, and I'm going to put some parentheses here because I'm recognizing that there are two functions here. So there's a 3x and then there's a y. And those are being multiplied together, which means I'm going to need some product rule. So product rule tells me to take my first function and leave it alone, and then multiply by the derivative of my second function. Well, the derivative of y, that's where that implicit differentiation comes in. That's my dy dx. And then I'm going to take the derivative of my first function, which is 3x. So the derivative is 3. And I'm going to multiply it by my second function, which is just y. And then let's see, I've got an equal sign, and the derivative of 10 is just 0. So now I need to find dy dx. Before I can do that, I'm going to have to distribute this negative sign to get rid of the parentheses. So I get 2x minus 3x dy dx minus 3y equals 0. So I'm going to right off the bat subtract 2x from both sides and add 3y, so that I can start to isolate the dy dx. So I have negative 3x dy dx equals negative 2x plus 3y, and then I'm going to divide both sides by negative 3x. So I get dy dx is equal to negative 2x plus 3y all over negative 3x. Now just to get rid of the negative on the bottom, I'm going to take out a negative so that I get dy dx equals 2x minus 3y all over 3x. So all I really did was factor out a negative on the top and cancel it so that I don't have a negative on the bottom anymore. But this is my first derivative. Alright, part B says write the equation of the tangent line to the curve at the point 1, negative 3. So we know if we're going to write the equation of a tangent line, we need two things. We need a point, which they gave us, 1, negative 3, and we need a slope. Well, the slope of the tangent line really just means evaluate the derivative at the point we were given. So we're going to have to evaluate dy dx at the point 1, negative 3, which just means plug it into our derivative that we found in part A. So we're going to have 2 times 1 minus 3 times negative 3 all over 3 times 1. So we get 2 plus 9 over 3, which means we have a slope of 11 over 3. So now we have our point and our slope, and we just need to write the equation. So it's y plus 3 equals 11 over 3 times x minus 1. That's our point slope form, and we just use what we have. Okay, now let's take a look at number 2. This is, I know, where we had some issues. So we're asked to find the second derivative given this first derivative here. So dh dt is equal to h squared times the quantity 6 minus 2t. So the first thing we really have to think about here is which of these variables is acting like the y and which one is acting like the x, because we need to know where the implicit differentiation comes into play. So if we look, the h is on top, which means that our h is actually the output. So the h is acting like the y. And then the t is the one that's actually acting like the x. What that means is that any place we take the derivative of h, we're going to need to remember to include a dh dt for that implicit differentiation. So let's see if we can do this derivative. So d squared h dt squared is going to equal, we're going to need some product rule here. So I need to take the derivative, let's leave the first one alone. So we're going to do h squared times the derivative of my second function. So the derivative of 6 minus 2t is actually just negative 2. Plus, now I'm going to need to take the derivative of my first function. So the derivative of h squared is 2h dh dt. That's where that implicit differentiation is going to come into play. And then I need to multiply by my second function, which is just 6 minus 2t. So I'm going to take just a quick second. I'm going to underline a couple of different parts here. So this h squared was this first function, and then the 2h dh dt is the derivative of that first function. And then we've got 6 minus 2t, that's my second function, which is right here. And the derivative of that second function is right there. So those are those different pieces that just came into play, and that's from our product rule. The dh dt is the implicit differentiation part. But now we know that any place we see dh dt, we need to take that out and we need to substitute in the original derivative. Before I do that, I'm going to simplify just a little bit. So we get d squared h over dt squared equals negative 2h squared. And then I'm going to take this and move it in front of my dh dt, so it becomes 2h times 6 minus 2t, and then it's times dh dt. Now this is where I'm going to take out dh dt, and I'm going to substitute in my first derivative that I was given. So d squared h dt squared is going to equal negative 2h squared plus 2h times 6 minus 2t times, this is going to be h squared times 6 minus 2t. This whole piece here is this dh dt that we were originally given. Now it's just a matter of simplifying a little bit more. So we're going to do negative 2h squared plus, now if I look, I have 2h and I have times h squared, so that's really 2h cubed. And then I have 6 minus 2t and another 6 minus 2t, so I can make that 6 minus 2t quantity squared. So this is actually our second derivative right here. So the hard part here is that not only did we have product rule, but we also had that implicit differentiation piece. And then we had to plug back in our first derivative. So hopefully that helps explain things a little bit more. If you've still got questions, please be sure to ask in class. Thanks for watching.